let us discuss the blood vessels. The human circulatory system is a closed delivery system that begins and ends at the heart. Keep in mind that when we look at this figure, it kind of looks like the the arteries are going down the left side of the body and the veins are coming back up the right side of the body. But keep in mind that pretty much everything is centralized and bilateral. So in other words, the descending aorta goes right down the center of the body, and the vena cava go right through the center of the body. It's just the way that they design these figures makes it look a little deceptive. So just keep in mind that everything is centralized and goes from one side to the other fairly evenly. Okay, keep in mind that arteries are structures that bring blood away from the heart, and veins are structures that return blood to the heart. Also keep in mind that capillaries they basically deliver they deliver blood to the tissues directly. They are the only blood vessels that have direct contact with the tissue cells and serve their needs. So when you're looking at a figure like this, you kind of want to keep in mind some, three biggies. We got the arteries bringing blood away from the heart and towards the tissues. We've got the capillary beds that are delivering the stuff within the blood or taking things away from the tissues. And then we have the veins that are returning blood to the heart. The structure of the blood vessels is quite interesting. Remember that when we're discussing structure, you should be immediately thinking in your mind, oh, this is anatomy. So when we look at the structure of blood vessels, it's kind of cool to look at this picture, which is an actual histological slice of two neighboring structures, an artery and a vein. Typically, the artery that is bringing blood to a structure, to an organ or a tissue, will be right next to the vein that is returning blood away from that tissue. In this picture, we can very clearly see some of the structural differences between the two. But for now, let's just talk generally about them. So there's a central blood-containing space. This is called the lumen. And then we have three tunics around there. Tunic means a wall. So the tunics here are three distinct layers which surround the lumen. In the case of blood vessels, the tunics go as so. The very inside, well, let's actually take a look at this picture here, which kind of delineates each of these walls better. So the centralmost layer, the layer that is closest to the lumen, is going to be the tunica intima, also called the tunica interna, and maybe more commonly called the endothelium. The purpose of this layer is to minimize friction. It is made of simple squamous epithelium. And yeah, so it always looks exactly the same, whether you're looking at arteries, whether you're looking at veins, or whether you're looking at capillaries. Every single one of these structures has exactly the same endothelium, exactly the same tunica intima, because the role of the tunica intima is just very, very important. So again, simple squamous epithelium. If you look closely, you'll be able to see each of the different cells inside of there. So it's living cells that make up the linings of these guys. Okay, the next layer is called the tunica media. The tunica media, here, and there's really not one here. It consists of circularly arranged smooth muscle cells and sheets of elastin. The tunica media is primarily responsible for vasoconstriction. And next we have the tunica externa, which is also called the adventitia, which is also called, actually that's about it. Depending on where you are in the system, it might be called a few different things, but basically it's called the tunica externa, and it's made of loose collagen fibers, and it's meant for protection and reinforcement and anchoring. So you'll have a tunica externa here and here, and there really is not one here. And just so you know, arteries and veins contain all three layers, and then capillaries actually contain basically just an endothelium, maybe just a little bit of supportive structure around them. And as you get to smaller arteries, such as arterioles, and smaller veins, such as venules, they may have lesser amounts of each of these three tunics. And also, of course, you will see immediately that there are structural differences between arteries and between veins. For example, the tunica media, which again is made of muscle, is quite profound in the arteries and not as well defined in veins. And that leads to, I mean, like you can actually see that very clearly in this picture. You may not be able to identify everything in this picture, but clearly you can see the lumen. And then also clearly you can see a very thick wall here of the artery, and which is the tunica media that you're mostly seeing here. And then you actually don't see it very well defined at all in the veins. And as a result, arteries tend to be much more uh, rubbery, more firm, whereas the veins tend to be much floppier.